Welcome everybody, good afternoon. My name is Rob Roy. This is the Think Different About Windows on Your Mac and Off session. I'll start off with giving you a little bit of background of myself. I've been a Mac tech at Sheridan College since around the year 2000. I worked there for about 8 years, and then I left Sheridan to go work for Apple Canada as a systems engineer covering higher education in Ontario. While I was at Sheridan and Apple, my background and the specialties I had were kind of related to deployment. So part of that was, of course, doing Bootcamp, right? Because that became a big part of that. At Sheridan, just to give you a little background, we're about 45 minutes outside of Toronto, just to the west, right along the lake. We are the largest arts campus in Canada, which is a pretty big feat. And we cover almost every discipline you can imagine in the arts community, from photography, filmmaking, design work, even down to things like textiles and furniture making and glass blowing. So it's an amazing place to work as a technologist, because you get to see all this amazing art being created around you all the time. We have on campus around 1,300 Macs that we deal with. I'm directly responsible for about 9 labs of those, so not the whole subset. We have a nice team that takes care of all that kind of stuff. But today we're here to talk about deploying Windows on your Mac and off. So before I even start, who here is actually deploying, say, Bootcamp now? You've got Bootcamp going? Okay, so maybe about half of you, that's good. This is not really a conversation on how to Bootcamp, because I think there's another session that's going to be about that, but this is about, Tim at the back of the room is going to be doing a session about that. This is kind of some tricks around that might make things a little bit easier for you. So we're going to just kind of break it up into 3 sections. Bootcamp via a virtual machine, which maybe is interesting to you. We're actually running a lot of Windows machines remotely from a Mac, so that the horsepower of a Windows machine is actually being used, and we're just kind of capturing that. And then at the end, I've got some really cool other tools and tips, which I think you'll find pretty interesting. I will say, hey, some of this is pretty experimental, right? We have not deployed this yet, but we are way down the testing path. So if you are testing this, I really want this session to be like an inspirational session to have you go back and try these things. Everything I'm going to show you today I have tested. I wouldn't be brave enough to come up here and say, I think this is going to work. I have actually seen this in operation. But just keep that in mind, that this is pretty experimental. And we're hoping to actually implement this for the fall. So by next year, I'd have some real working data out of this. So the first idea is moving Bootcamp from being built on a specific Mac machine to actually building it onto a VM, and I'll go into why. So by the numbers, we have a lot of machines running Bootcamp at the college, right? In my program alone, I'm in the Bachelor of Interaction Design. It's a very cool kind of program where it's teaching students about design work, but also in interactive ways. So we're doing things like HoloLens work and Oculus Rift work and Raspberry Pis and Arduinos and all that kind of stuff. And so there's a lot of reasons we need to have Windows for especially things like a HoloLens, right? So we have about 173 machines in my program alone that we're doing Bootcamp on, which you can imagine can be kind of daunting to deploy that many. We have about 45 in other lab-based programs. So our design program has AutoCAD, those kind of things. And then we have some full laptop-based programs, like our interior design, that use things like AutoCAD too. So we're deploying it in large numbers all over the place. And so here's the crux of the problem, is that I don't have one type of Mac to deploy on. I have several types of Macs to deploy on, right? So you can imagine if I had the same iMac in every single location, I can create a Bootcamp image. I'm going to be pretty secure it's going to work on any one of those machines. But the reality is we're still running some 2012 Mac Pros. We've got some 2013 Mac Pros, a whole bunch of different iMacs of different generations. And then the laptop programs are all mix and match too. The students actually have a choice of what kind of level of laptop they'd like to bring. So we have a lot of variety of machines that we're trying to implement the software on. And so last year, I'm not the Windows guy, I'm the Mac guy, but I work with the Windows guy, Mark, who develops all the Windows images for our department. And so last year, he had 6 separate Windows Bootcamp images, right? Like I said, the 2012, 2013 Mac Pros. We had some older 2011 27-inch iMacs, which were considered legacy machines in terms of deployment, right? And then we have some 2012s. And then we had some newer 4K and 5K iMacs. And those, had some problems too, because you'll see that in a minute why that would be. So one of the issues are you need custom Mac drivers for each hardware type, right? A lot of times they have different graphics cards, and you never know what kind of things are going to be in there. So that's a challenge, right? That, again, it starts to open up the field if we have to create multiple images. One of the other issues that came up too, I noticed when Mark was working, is that he would be working on an image, and he's got literally 6 Macs in front of him, and he's kind of going to one and doing something, going to two, and he would maybe install some piece of Windows software that would just break something, right? And so what did he have to do? Well, as he went along, he would get to a certain stage, and then he would create an image out of that, right? And then when he's doing the Windows development, something breaks, he's got to go back, wipe the machine, re-image the machine. So he's losing like an hour probably in that process, right? We also found that deployment was very inconsistent. Mark would create these 6 images, and sometimes you might be able to shim one onto a different piece of hardware, but sometimes we're deploying them. We would normally try to take a package and then put that into Monkey to deploy. Sometimes that just would not work. So then he would have to take that, image it into Deploy Studio, and use Deploy Studio to lay it down, right? Very inconsistent on which way would work for whichever piece of hardware we had going. And then the other thing I was talking about with those 4K and 5K iMacs, in post-2015 machines, they had this 4K block size on the disk, right? So you couldn't use that image onto a different iMac because the block sizes were different, right? So again, all of these things just conspired to create multiple images in multiple time, right? So my thought process is there has to be a better way. I love looking at something complex like this and just seeing the stress that Mark was going through getting all of this work done and thinking, there's got to be a better way to get this done, right? I always consider if I can write some software that will speed this process up, it's going to give me more time to write more software to speed up another process, right? So I'm always working to try and make our processes better. So I had a brainstorming session. I said, well, how can I make this generic across multiple machines, right? I hate the fact that it's got to be on all this different hardware. I want to make that as generic as I can. How do I get it back to a known good version if the setup's going bad, right? We don't want to waste an hour. Again, if we have 6 different machines and it's broken on all 6, there's like 6 hours of time gone, right? The other big challenge is I have to have 6 machines sitting on my desk. I don't have that much desk space, right? So that's a bit of a pain. And then we want to make the deployment super reliable, right? We want to know that this is just going to lay down on all these machines as you would expect it to. So in the brainstorming, I thought, well, what if we could create a virtual machine, right? Some of the magic of a virtual machine is you can kind of create that machine and then it will run pretty easily on different pieces of hardware. So we could maybe start to build one base Windows image that could then be used on different pieces of hardware because it's all so base to begin with that it's much more vanilla flavored and reusable. The stock driver, so when I just installed it into VMware, I did not even install the VMware drivers. I literally just put the OS down and just for my testing, just to pick it up and move it. And every time I picked it up and moved it onto a Mac, it just worked out of the box without even having to put in the Mac drivers first. Because it got down to the VM was such a vanilla flavor of everything that it just seemed to lay out on any piece of hardware and work for me so far. Again, knock on wood, this is still very test-worthy. The other amazing thing about VMs is you suddenly have snapshot capability, right? So now if something tanks, you're installing a piece of software and it goes south, you roll back to the last snapshot. Now you're 2 minutes up and running instead of an hour up and running, trying to re-image that whole process, right? And the other great thing is like you know, when you're ready to sysprep, create a snapshot, sysprep, right? And then you can roll it back, so you haven't sysprepped, do some more tweaking to the image, sysprep again, right? So with this rollback scenario, you can sysprep a million times and it's not really doing anything detrimental to the image as you're creating it. So I began testing with VMware Fusion because this is just what we happen to have licenses around. So everything you'll see today is kind of based on VMware Fusion. It may also work in Parallels or something else. I don't know, right? I've just tested it with this. And also, the thing I'm about to show you was actually something I found as a write-up on Happy Mac. So I didn't kind of discover the magic of using this VM in the way I'm about to. Well, basically, the Happy Mac article, which is what you're about to see, is you can take a real physical hard disk and make that the disk for the VM, right? So instead of creating a virtual disk inside the VM, we're actually taking a real physical disk and making that the VM disk, okay? So my setup was, because I wanted a real physical disk, the easiest thing for me was I grabbed one of our Mac Pros, because we could have multiple drives sitting in the Mac Pro, right? So the 2 drives in there, one of them is just for OS, right, the bootable Mac OS running the VMware stuff. And then the other one was the actual physical hard drive that we would actually turn into the VM drive. So to begin the process, I just created a VM just from scratch, saying it was going to be an OS 10 or a Windows 10 machine, right? Just started up that process to get kind of everything in line. And then we wanted to go in and actually take the physical disk and turn that into the disk for the VM. So inside, so I'm going to step through these so you can see them. So sudo, obviously, it's a big step. Inside the VMware Fusion app itself, there is a tool in there called VMware Raw Disk Creator. And that's exactly what it's designed to do, is take real physical disks and turn them into the disks for the VM. Okay? So we just give it the create command. We grab whichever that disk is. For me on the Mac Pro was dev disk 0. And then we say we want that whole full device taken up to be the physical disk. And then we put in the path to where that's the VMware VM file is located, right? The one that when I created the VM, it created this file, which is the actual VM. And then we name this disk whatever we want to name it. So I just called it internal dash disk, right? You can call this whatever you want. This is just what the name of the disk is going to be as seen by the VM. And then we tell it's an IDE disk, okay? So then you have to chown it, right? Change ownership to admin staff. And again, we're going inside that documents folder down to where that, this internal dash disk.vmdk, that is like the physical pointer to the real disk now. So we just have to change the ownership on that to admin and staff. Change it to 755, same thing, we're doing it to that actual disk container. And then once that is done, so that's kind of the initial prep, then inside of that folder as well, you'll find this .vmx file, and this just contains more information for VMware. And inside that, you just have to add these 3 lines. We say it's present, it's true, this is the name, and boom, and now it's ready and operational, okay? Then I go back into the VMware setup again, and I change the drive that would have been created, right? On first VM creation, it's going to ask you to create a drive, so I just said, yeah, create me a whatever. I go back in here and I point it to that VMDK, okay? And now whenever VMware spins up, it's going to use this real physical disk as the disk for the VM, okay? Then I would go along and install Windows just like I would on a real Bootcamp partition. I don't install the VMware tools. I leave those completely off. And then I just go ahead and start installing applications and snapshotting, right, as I would throughout the entire creation process and rolling back where necessary and so on. And then, so now we have really a full VM ready to go that's very generic, right? It can kind of go anywhere. But we now need to install the Mac drivers to this VM so that, at boot time, we can get this ready to actually run on the real hardware. We want all the drivers in to know that the video is going to be perfect and all those kind of things. So what I did was, as part of our workflow at work, we typically have 3 partitions. We would have the Macintosh hard drive. We would have what we consider a work disk, which is about a 50 gig slice we leave for the students, so they can temporarily store things there. We tell them it's wipeable at any moment, so don't rely on it. But it's there. So what I did this time around is I turned that into an exFAT partition. So now if I'm booted into Windows, I can still use it as a work disk. And if I'm booted into the Mac side, I can still use it as a work disk, right? It goes both ways. And so then using the Bootcamp Assistant, in case you're not aware of this, under the Action menu, you can actually download the proper drivers for that Mac. So whichever Mac you're on, right? If I was doing this off my MacBook Air here, I'd be getting the proper driver package coming out for this MacBook Air. So I just go to every single Mac that we have to deploy to, and I download these Windows drivers for each Mac. And now I've got that kind of ready to go. So then I would just take that package, I would put it onto the work disk, and then as part of the Windows setup, usually Windows does 2 or 3 reboots to go through its entire setup process, I would just put in the script there, run this package that's sitting on that work disk, and that would install the proper Mac drivers for that machine, right? So at deployment time, we could do it then. We can use a package, like something like Monkey to drop it onto that work disk, or we can use Deploy Studio to say drop this package on that work disk, and then it can be run out of the Windows side. The other option, so this is my idea, our Windows guy has a different way to work, and so he uses a tool called Driver Magician. I don't know if anybody's heard of something like Driver Magician before? A couple of you? So what Driver Magician does is you can go through and, so say I went to my iMac and I installed all the Mac drivers in the Windows side. I would run Driver Magician, it would pull out all the proper drivers and put them in a folder, right? Then I would go to the Mac Pro and I'd run it over there and it would grab up all the drivers into one folder. And then we would take all of those drivers collectively, put them into one folder, and then put it into the Windows image itself. And then on first boot, the Windows image will go through this driver folder and then auto-populate the proper drivers it needs. It would have all of them in there. So it's a little bigger storage in the image, right? Because you're actually going to put all of these Mac drivers, potentially 6 different types of Mac drivers in this folder. But then it's kind of all the work is done, and you create the image and you go, right? You don't have to do any post-scripting to get the drivers in and operational. So that's another way to go. So the beautiful thing about doing it this way, and to be honest, when I started this process, I tried to just create a virtual disk in the VM. But the problem was none of the tools would see it and pick it up, right? But because I'm using a real physical hard disk, when I launch the beautiful WinClone, WinClone sees the disk, right? It's on the machine as if it's a real partition or a real volume. So it instantly sees that untitled volume, which is our Windows master. And then I can use WinClone to actually create that package, right? So like none of the back end has to change. If this is what you're using WinClone to create your Bootcamp, it's exactly the same. Except now we just have a way more flexible partition to start with, right? So we could then pick up that package and then use Monkey to, say, deploy that package out, or however you'd like to deploy it, right? It's exactly the same workflow as you would normally have. Here's a little tip in case you're not familiar with this one too. When you open that WinClone package, you'll find this settings.sh in here. Inside that text file, you'll see there's a slice number there, slice number 4. You can actually change that slice number. So I've gone on to take it on my Windows and put it onto slice 3 or slice 2 or whatever, right? Because one of the challenges that's happening is when you move to High Sierra, we've always typically been slice 3 for putting your Windows on, right? So everybody's kind of used to slice 4 as being the magic. If you go to APFS in 10.13, it may not be slice 4 anymore. It might be slice 3, right? So you could change that here. In fact, for us, because we put the work disk back in, then it became slice 4 again. It's kind of a nice little bonus for us to make that happen. That's a nice little tip to know about modifying that. Are there any questions on that part at all? No, you guys are pretty quiet, a little comatose after lunch, maybe? All right. So that's really how to just slightly modify what you're doing and maybe get a little more, custom, or a little less customization, a little more generic content, and then make life a little bit easier, right? And so instead of creating 6 images, I might just be creating 1 image, right? So the second thing we're working on this summer is remotely controlling Windows machines, okay? So the question becomes, is Bootcamp always necessary, always needed, right? In our program, we run things like the Microsoft Connect, right? That can do like human tracking for doing all kinds of artwork. So the Connect definitely has to connect to a Windows machine via hardware, right? It's a USB device we're plugging in. I have to have Bootcamp. There's not really a way around that. Likewise, we do HoloLens development, which is like a VR, AR headset rig, and that really needs to talk to the hardware at certain points to upload content and that kind of stuff. But there's a lot of times when we don't really need to have Windows directly on the machine, right? Maybe I'm just going to do some sort of high-end render through, Rhino is a typical one that we use or something. So we don't have to have it directly here. We could actually, migrate the data off to another machine and be able to use it remotely. Again, I talked about, we have one Windows technologist, right? So having to put all of this Bootcamp on every machine takes up a lot of his time. And if we can, what we're going to do is actually create a server farm full of machines that is going to be less work for him in the end, right? The other challenge we had is we have classes that need Windows, but we don't have Windows on every single Mac that we have, right? So scheduling becomes a problem. If we have a class that needs to be in Windows, but it's one of our arts labs, they're going to have to book into a Mac lab with Windows, right? Which is a little difficult to schedule properly. So the other thing that we have that's kind of unique maybe to us, and I'm sure not everybody has this kicking around, we have our digital animation, and gaming programs are all running on HP Z620 workstations, right? And so this summer is a big lease rollover for us. So we suddenly had, 300-400 machines that were about to walk out the door that we could capture essentially for free, right? And then put into use as these remote workstations. So the ones we chose were the workstations with Quadro graphics, just because more of our software going to be running like AutoCAD would take better advantage of that. All the gaming ones, of course, had some sort of NVIDIA card, which is great for gaming, but not always great for high-performance computing. So they were coming off lease in large numbers, so we said, hey, let's take some of these, we'll put them into a big installation, and then be able to remotely control them. So HP themselves make this software called Remote Graphics Software, RGS. And it just allows this idea, what it's doing is it's doing all the computation and all the graphical rendering on the workstation, and then just throwing you a window so you can see that, right? And you can run that, the server itself can either run on Linux or Windows. It runs on the HP Z-Class workstations. And the client software is free when you're running on Z-Class workstations, and the server software. So there's no extra cost to us that way. We're getting all these machines going off lease. The software is completely free from HP, so it seemed like a slam dunk to put them together. So here is a photo of part of the installation. We put in 80 machines in racks this summer. So you're seeing about 60 of them here with another 20 on the other side of the room. So that took a lot of work. We actually had to repower part of the room, right, for all this horsepower. We've got two, I think, 30 amp circuits going to every one of these racks. And then we haven't networked them yet. That's coming shortly. That's going to be a big job as well. But it's nice that it was all rack mountable, and we can make it look kind of pretty and put it in the back room and then not really think about it again. So then the challenge becomes, we've got 80 machines sitting in these racks, but how many clients do we have? Where are the clients, right? How do we map somebody when they walk up to a Mac to go grab a machine, right? You can't just do a one-to-one mapping. Machine one goes to this machine one and machine two. So we had to figure out some way to round robin this, because we've got 80 machines, so we could have 2 or 3 classrooms live at one time doing this work. What happens if a machine goes down? How do we know that? How do we deal with that? What happens if somebody logs into the machine, does all their rendering, and then forgets to log out? Right? There's all these things you got to think about when you're doing remote computing. So what we did was Applescript to the rescue, right? I'm a huge Applescript fan. I love writing in it. And so I created a script that would launch on the client Mac and then do a couple things. So it launches the script. We've created a folder on a share that actually has the known good and operational machines in there. It's a bunch of text files. We can kind of make this as simple as we can. So it looks inside there, finds a text file which indicates a machine is ready to go. Then it remotely logs into the RGS client and pops it full screen. And then the user can then log in with 80 credentials to that machine. Okay. And then we can also mount a remote volume. So if the student has some work they need to render on that machine, they could dump it from their client Mac onto the remote volume, and then on the remote Windows machine, it would mount there, and they could drag it off to do the processing and back and forth, right? That's kind of our conduit to get through. So I said the Applescript launches. It does a mount, and it actually does a no-browse mount. So on the Mac, nobody sees this, right? It just happens. It would show up on the desktop, but we've done no browse, so it doesn't show up. And then inside there, we have a folder, and inside that folder is a bunch of available RGS machines. Okay. So how do we know which text files are in that folder? Well, we did that on the Windows server side, right? Each one of these machines. So when the machine boots, we have a login script that creates this text file in this location, right? So hopefully if we go to get this text file, it means there's a booted machine there, right, ready to go. When the user logs out, we would put it back there again to indicate we have a machine ready to go, right? It's logged out, it's ready for the next user to pick it up. And then if it shuts down, we actually remove the text file out of the folder, right? So it's no longer available for somebody to pick up because the machine's been shut down. We have to go and reboot it now at some point. And so I created so just so you can see, I'm not going to go through every line of this, but it's a pretty short Applescript. And I'm just going to go through it just to show you what it'll do. So it'll remount mount the remote server with the folder full of machine files, right? It then sorts that folder by the oldest machine, because we want to really round robin these and not just grab machine 3 all the time, right? So it's going to be whichever one hasn't been touched the longest gets to the top of the pile. We copy the URL of that machine, and basically the URL is whatever the name of the text file is. So it might be rgs01.txt. So we will grab the rgs01 out of that, and then append the @sheridanc.on.ca, right, in the Applescript. Then we delete the text file. Once we've picked it up with Applescript, we know that we're going to use this machine, we delete that text file. So hopefully this is in a couple of seconds, so the next person that launches this, that machine is no longer available, right? If there's an error, and the error would really be there's no text files in this folder, then it's like, hey, contact support, and we've got to go figure out why we've lost 80 machines off the network. So I don't assume we're going to have that problem, but you never know. Then we unmount that server. We're kind of done with that part. We grab what we needed of that, which is the URL of the machine. Then we launch the RGS app, and we log the user into the RGS client, right? So there's kind of 2 logins happening. We have to log into the RGS client, and then we have to log into the machine. So we've set this up so the script is actually logging into the RGS client. And that way, nobody can just kind of wander around and grab a machine by just typing in the URL, right? They're not going to know the login for that. Then we take that window and we blow it up to full size and show it to the user. And then we throw a little dialog box in and say, hey, please log out when you're done with this, right? And my other intention is I'm going to make the desktop pattern say the same thing, like please log out, please log out. Don't just hit the red X and then we have a machine just sitting in that state. And then it quits the Applescript. So I've got a little demo here, so you can watch along. So down at the very bottom here, you see this launch RGS that just bounced there. So that's actually my Applescript. I took the icon of the actual app and I put it on my Applescript app, right, and changed the name. So to the user, they think they're just launching RGS. It looks like the real deal client. So that bounces for a couple of seconds. Now it's actually, so in the background there, during that bounce, it did the mount to the remote volume, picked out the machine out of that folder of available machines, deleted that file, and now it's going on to the next part. So then it launches the real RGS software. It drops the URL that it found into the window that you see there. I'm just using GUI scripting to do all this kind of stuff. So it just drops that in there, and the connect happens. And here's where I'm throwing in the admin username and password, right? Now it's launching this, bringing up full screen. And we're still kind of toying with resolution, so right now this is a bit of a window, but what we're hoping is to actually go full screen. Again, the other challenge of having 6 different types of Macs is I had pretty much 6 different resolutions, right? And then I throw this little dialog box at the end saying, you know, please log out. What I'm also hoping to do is just center that file. Right now I'm just saying move that to 0, 0 and make it full screen, right? So I hit OK. Now the user can log in. So again, this would be a full 80 login with username and password. And then here's the actual remote machine. So what I did is I ran the fuzzy donut test on here, which is like a GUI stress test. And so if you're seeing any kind of hesitation here, it's probably from the video recording, because this is like buttery smooth on my desktop. And it's hard to see, but at the very top there, you can probably see it's running at about 83 frames per second, right, over the network. It's pretty impressive, because this is in my office and the server room's like 3 buildings away. Right, so really, if you have to run Windows software, but you don't need to have it directly on the machine you're on, this is a nice way to be able to remotely do that work, okay? So what are the challenges? So like I said, I have the Applescript authenticate to the RGS login, so nobody can just grab these machines willy-nilly, right? If they forget to log out, we're going to have to do like an idle timeout, right? If the machine sits idle for 4 hours or something, then we'll log the machine back out and put it back into the pool, right? And the other challenge is Applescript is doing great for handling our Mac clients, but occasionally we may have a Windows client that we may want to grab this. So we have no round-robin association for the Windows client yet. Now there was some third-party software that we'd found. Actually, HP used to make like a round-robin software themselves, and then they stopped developing it, and it apparently was really good. There's a third-party piece of software out there, but it was relying a lot on Java, and I'm not a huge fan of that. But if we go down that road, we may have to implement it that way. I'm hoping maybe with PowerShell we can figure out some sort of round-robin solution as well. But anyway. So that is what we're heading towards this summer. Like I say, we're really right in the middle of, we just got all the hardware racked, the image is being built for these things. And so we don't actually have any real world, like we've done some testing. We've had faculty hammering on it with Rhino and certain other pieces of software, and they seem to be quite happy with it. But we haven't really deployed to a mass of crazy students. So that'll happen this fall. So we're hoping it holds up under stress, right? Are there any questions on that piece at all? Yeah?
Is RGS then a one-to-one? I mean, I know you're about Robin, but ultimately you're delivering to 80 clients.
Yeah, exactly. Yeah, it's no, yeah. There's no kind of virtualization. We're really controlling real hardware at some point. Yeah. So.
That would give you ultimately, in theory, better performance than a Citrix or some other multi-user.
Yeah, it's like super high power. Like you're really running the full HP workstation at that point. Like I say, 83 frames kind of over the network is really high powered. Yeah. Sorry. Oh, so the question there was, is it one-to-one? Because we have the microphone we're going to pass around. And the answer is yes, it's one-to-one at this point. Right? Any other questions? Yep.
Is the RGS software a Mac app that HP provides?
It is, yeah. So HP builds the client application for Linux or Windows or Mac as well. So yeah, you just download it off their website, and that's completely free. And like I say, you could run, I think you could run RGS on other non-Z class workstations, but there's a cost to it. But when you buy the Z class workstations, like the Z6 and Z8 series, then you could just download and run the software, and it actually kind of knows that it's running on a Z class workstation, and it just does a hardware authentication, and then it works like that. Yeah, did you have another questions? No? Okay. Anything else? No? Oh. Yeah, so what software are we using that pushes the hardware at the moment? So yeah, Rhino is a big one. Trying to think, so Visual Studio we're using for the HoloLens work. We also are running AutoCAD. Some students are probably running AutoCAD on that. Trying to think of what else we have. But it's mostly, yeah, like big 3D. 3D is kind of the biggest reason we use that. Because we also, the other thing I didn't mention is we also have things like 3D printers at the college. So a lot of students are actually like building a lot of 3D objects. And also even in our kind of cardboard design programs, they might build something completely in 3D and then unfold it into cardboard. So it's mostly 3D processing that we're doing through those kind of tools. Yeah. Yeah. Okay. So the last section I want to get in here, I'm just going to grab a little water, is some custom tools and tips that I've kind of designed along the way to help out with these things. So, when you're running Bootcamp, one of the things you have that is a problem is you have to option boot, right? There's very few third-party tools, with the exception of Boot Runner, which our friend Tim, if he's still here, does through Two Canoe software. But most times you are really holding down that option key to boot to the Windows side. So what are the challenges there? Well, one of the challenges is our Mac Pro 2012s have about 28 gigs of RAM in them. So when you hit the power button and you're holding option, the post is checking all of that RAM, right? So we have like 20, 30-second wait times before option kicks in, right? So that's like you're waiting and you're waiting and you're waiting. The other issue is, of course, if you have option boot available, people could walk up with their own hard drive and boot whatever OS and take whatever they want off your machine, right? And it's kind of a security risk to have option booting out in the open. And then we found in a few instances where at podiums we had Mac Pros, and the Mac Pro was so far from where the screen and the desktop was that we had to have 2 USB extension cables in there. And that would literally kill option booting. For whatever reason, holding down option would not work when there was 2 USB extension cables in it, right? So occasionally you'll run into some weirdness like that where it's just not going to do what you want. So I built this little app called Get the Boot. And Get the Boot is kind of like, if you remember Boot Picker from the old days, and there may be some other choices out there. So it is just a little window that crops up right in front of the login window. Right? So that's why you don't see the login window here. My app's in front of it. And it's just 2 giant buttons. One is Mac and one is Windows, right? Pretty simple interface for anybody to use. And so it's really a simple Swift app. Like this is my first Swift app. I'm not a huge developer. I do a lot of Applescript and shell script, but I haven't done a lot of real scripting. Although in the old days I used to do Applescript Studio when that was the thing. That was awesome. I loved Applescript Studio. You could actually hook Applescript into real GUI buttons and stuff. I'm going back a few years. So what does this app do? So clicking on the Mac OS button really just quits the app, right? And when it drops the app, you're right at the login window. So you just log in. Piece of cake. When you click on the Windows side, it does a one-time boot to Windows, right? It does a bless command to the disk. says next time only go to Windows. So it goes into Windows. When they're done with Windows, they reboot the machine. It automatically comes back up to the Mac and back to this app, get the boot, right? And then my coworker, Mark, is actually pretty smart at sometimes. He's like, hey, what if you did this? And he said, well, if I actually click on it to make sure it's the in-focus application and I hit Command-N on the keyboard, it netboots to our netboot server. So I can walk into a lab and have no other tools in my hand and just click Command-N and I'm netbooting that machine back to the server, which is kind of cool, right? So I'm just going to show you a couple small things. So there's two scripts really that are happening, right? When I click the boot to Windows, we get this script up. In this script, I'm just going to show you some customizations I had to do. This may be being pulled out as we go because we're probably not going to need any of these things anymore. So I do a system profiler's hardware data type. So I need to know which machine this is running on because I want to make this very generic. It'll run on any of my Macs. And so it'll go through and get the model identifier for that machine. And then I have two variables there. Is it the old Mac Pro, the 5.1, the 2012? I can compare against that. And is it our old iMac, the 12.2, which is, I think, the 2011 iMac was, like I said, considered a legacy machine. So it blessed a little bit differently. So once I've figured that out, then I just do a quick comparison. Is the Mac type, which I actually got through System Profiler, is that equal to the old Mac Pro, the 2012? If it is, then boot from this. We basically, in the old Mac Pros, had put in an OWC sled with an SSD in there. And that's the one we booted from and worked from, right? So if it was the old Mac Pro, then that was disk 1S1, because it was the OWC sled in there, right? And then the spinning disk that would be the 0S1 is still in there as our work disk. So I do that first check. Is it an old Mac Pro? If it is, then set the disk to be this, right? Is it the old iMac, which we no longer have, so this line is probably going to come out. Then I have to do the old style boot, which is you'll see the -- legacy in there, right? That was what you needed to make that 2011 iMac do its net booting. And if it wasn't, then we have to get the UUID of whatever the disk is we're going to be using. So you'll see there the disk util info EFI disk. So that was the disk 0S1 or 1S1, depending on the machine, right? We get the UUID of that. And then this is the array that we blast into nvram, right? And this is what causes it to actually netboot to the proper location. So here I just called it in black the UUID that we had just gathered and the EFI disk that we had gathered in the first place and put those in. And then the actual command is we just do the nvram command, say EFI boot next, which is next only, right? And then the arguments for whichever disk we're going to go to. So that's all that took. And then if I wanted to netboot the machine, same sort of idea. We're doing a bless to netboot, right? And then it's just there's kind of three different parts to this. So the TFTP you see there, that's the netboot server IP address. And then a little further down, you'll see a deploy.nbi. That's the name of whatever your NBI is if you're using Deploy Studio or something. So, and this is kind of all really legacy stuff, right? There's better ways to do booting now, but if you wanted to boot Windows or if you wanted to boot netboot this way, I had to go back to the old legacy stuff to make this all work. So basically, there's the booter part there, the kernel cache part there, and then the options, which is actually pointing you to the actual OS you'd be booting from off the netboot server. So you'll notice there that I'm using the bless command, right? Does anybody actually use the bless command? Am I one of the, a few people? Okay. So the bless command is a way for you to tell the machine to boot from a specific disk, right? That's what bless was always designed to do. Boot off this hard drive versus booting off this hard drive, but you can push it to, bless to a netboot server. So Apple built a system setup tool. I don't exactly remember which OS this was put in, but it was supposed to replace the bless command. Apple didn't really want you to do the bless command anymore. But, and I don't know whether everybody's found this, when I try the second line there, when I try to do a set startup disk, which is how it operates, I can never set that to a Windows machine to Bootcamp. Has anybody actually ever got that to work? Or am I right on that one? Okay. So the new tool that Apple's provided does not work for blessing to Bootcamp. So that's why I have to go back to the bless command again, which they don't want you to do as much anymore. So one of the challenges with the bless command is that you're writing to nvram, right? And now we know, hey, this new cool thing called SIP came out. It doesn't like me to bless, or it doesn't like me to touch nvram, right? There's certain places it doesn't want me to work, right? So in order to make all of this work, I'm going to have to turn off that part of SIP to make blessing work, okay? So what does that mean? Typically, now we're going to have to boot into the recovery partition, right? That's where we make changes to SIP. So if I'm doing that, I might as well do some other things. So hey, while I'm in there, I might as well set a firmware password because I can do that in the recovery partition, right? I can also put into SIP some netboot servers so that they're okayed by the OS to netboot to these netboot servers, right? And then I might as well make sure, because I've set up this whole nice get the boot system to actually do the booting properly. While I'm in there, I might as well make sure it boots to the Mac every time, right? I'll set that to be the bootable OS, okay? So in reality, that would be these commands, right? So I would boot into the recover partition, probably launch the terminal, and I'd run these commands. And so in case you didn't know about this top one, csrutil is the command to turn on and off SIP, right? Usually people know that you can do SIP disable or SIP enable, right? Fully turn it off, fully turn it on. But if you weren't aware, you can actually enable parts of SIP. So in this case, I say enable SIP, but without nvram, which means the nvram is open and available for me to bless to, right? That's the reason I'm doing it. So it doesn't have to be a full on or full off operation. When you do this, Apple will give you a little, hey, just so you know, this isn't fully accepted, may fail, but you could do it. You would also use the csrutil and add the netboot options in there, right? So netboot add IP of your netboot server, right? And you can add as many of those as you want. I just threw 3 in here so you can see. Then I do an nvram-d for delete all the boot arguments, because I'm going to want to set this to boot to the Mac OS. So doing D is just going to pull any boot arguments out. And then I do the bless -- device to the actual bootable OS. Usually disk 0s2 is your Mac HD, right? And I say set boot. So now the next time this machine boots, it's going to go there. And then the last thing you can actually do in the command line, which is very helpful, is you can actually set the firmware password, right, using the firmware password utility. So here you just go through to the contents resources. There's a set reg prop tool. That's the actual tool that's setting the firmware password. And then you put in for -p for password, and then here I just put in my firmware password. You'd put that to whatever you want it to be. And then -m command means it's going to do it, right? So I could go through there and do all of this work in terminal, in recovery partition, right? But how would I possibly do that efficiently on a number of Macs, right? Like I said, I've got 173 that I need to bootcamp, me personally, let alone the other several hundred that we have going on. So this is where the pay attention, because this stuff may just change your lives, I'm hoping. I know that's very boastful, but I'm hoping that you'll feel the same way. This is the whole reason you came to this presentation here today, okay? You could take all of that code and turn it into barcodes. And if you've never seen this before, I love it. So I would take that entire mess of text and I would turn that into barcodes, right? And then I would wander around from machine to machine and just go zap, oh, look at that. Zap, look at that. Zap, look at that, right? So this used to be a big trick, and it's going to get better than this, so don't be too wowed by this yet. But this used to be a great trick if we had brand new Macs out of the box and we needed to netboot them. I would put them on the table, go into single user mode, bang, bless it to netboot server, and we're off and running, right? So I never had to type anything. My fingers never got tired except for my trigger finger. And I could just turn any command into barcode. Very cool. But it gets better than that. So with modern technology, so I've actually been doing this for a number of years, right? So I just did the demo. Awesome. So with modern technology, you can replace the barcode scanner with something like an Arduino Micro, right? An Arduino Micro, amongst a few Arduinos, maybe like 5 or 6 of them, can actually be turned into functioning keyboards with some extra software. So I downloaded this HID-project library from a gentleman named Nico Hood. It's actually in the Arduino library pool, so you just open up the Manage Libraries area, look for HID project, download it, and then you can create an Arduino script that types for you, right? So up in the very top, you'll see that void setup area. This is our, like, hey, Arduino, this is our kickstart. So we just get a boot keyboard begin there, right? So the keyboard comes up and active. And then down below, you'll see I just have a different line for everything I want to have typed out. So boot keyboard.print line, put in quotes, everything you saw in that script is now there and good to go, right? And at the end, you'll see I added a reboot. So now I don't know how to do that. I literally just boot up a machine, plug this thing in, types all the lines, finishes, I unplug it, go to the next machine, away you go, right? So let's see that. So here's my Arduino Micro with a nice little 3D printed case on it, right? So here I just have a plain text file, but you can imagine I would be doing this in the terminal. And I plug it in, and course, the demo gods are not with me today. All right, let's try that one more time. There we go. Boom. So that's how quick it types. I unplug the cable, go to the next machine, plug it in, plug it in, plug it in, right? 173 machines in maybe a half an hour, right? Super easy, very reliable. I'm never going to mistype something, right? The Arduino is doing all the proper typing. It's great. If you see any spelling mistakes here, it's because TextEdit's tried to fix something it doesn't believe is right. But when you throw it into terminal, it works directly. Okay? So here's the super tip, right? As if that's not good enough. I know you're excited. I can see it in your faces, but here's the super tip. So booting into the recovery partition takes a long time, right? I timed it yesterday, minute 33, to get up to me actually opening the terminal, right? Holding Command S while booting gets you into single user mode very quickly, but we're in single user mode. We cannot do csrutil, right? We cannot do firmware password. But here's the amazing discovery I found somewhere in some little text on a forum earlier this year that I'd never heard of before that blew my mind. You can hold down Command S and R and go into single user recovery mode. So in 13 seconds, you're up to recovery mode in the single user command line. You plug that thing in, it's done. So 13 seconds per machine, and you've got all this work done, right? All of this, by the way, I've put some blog posts up, so don't worry about making too many notes. You're going to have that available to you. Okay? Now there's a super tip on the super tip. You can use ARD to reboot your machines into single user recovery mode, right? So here we're doing another nvram with the boot args, and we're blessing the 0S3 slice, which is typically the recovery slice. So I put a little caveat at the bottom that may be 1S3 now with APFS, right? Because we're all inside that volume now. So we basically set to boot to the recovery partition, and then you see we're adding the boot args of -S, which is single user. And then we say shutdown-R, which is restart. So I can take an entire lab of machines, blast this ARD command to it, they'll all come back up into single user recovery, and I just walk around with this key, and I'm done in minutes, right? Completely good to go. And now I've got all of the blast commands sealed up, they're secure, you can't option boot anymore, it's got the firmware password, it's like all done, signed and sealed in a matter of seconds, so it's very cool. So all of the code I showed you today is available at my website, which I'll just show you quickly. Oh, here's by the way, the barcodes, there's a ton of free barcode generators on the web, right? Just do a Google search, and you literally just type in here, whatever you want, and hit the generate barcode. And over here, you'll get the barcode, and you just download that and then plop it into, I just plopped it all into pages, and then, kind of shrunk it down so it's about half page size, and it makes it nice and easy for the barcode reader. So also my website, I've just put up 3 kind of basic blog posts. Build your bootcamp image in a VM, so that gives you information controlling the RGS machines. And then where I could, I actually threw the code in, right? So here's all the Arduino code. So all that stuff is up there and available for you guys to get, and I think you'll probably get the slides after the fact. And with that, we're kind of done a few minutes early, but I'm open for all kinds of questions. So, yeah, I'm just going to throw the mic around here. Ooh, good catch.
As far as all the HP machines and all that technology and money you spent,
Yes.
did you consider looking at the Citrix systems and graphics cards for those?
Well, we were kind of in the great space where we were about to just, all that machinery is going off lease. So for us to keep it was just going to be a zero cost solution. Yeah, which is why we went that way. And we knew that because we had, we bought these machines for both animation and gaming, so they were like already maxed with RAM and video cards. They were already like really nicely set up. So it was just super easy for us to grab those and work with it. Yeah. One of the challenges was, like I said, we have one Windows guy, and he kind of works in my department, but all these other departments that need Windows don't have a Windows guy, but they're kind of leeching on our guy to get the work done, right? So we were like, if we can offload a bunch of this stuff onto these machines, now we're only maintaining those 80 machines, and they're exactly the same, right? Every piece of hardware is the same, so we have one image. And then whatever clients can kind of grab it and use it as they like. And it was going to take a big load off of the Windows work side as well. Yeah.
Way back at the beginning, using using VMware, to set up a physical disk?
Yes.
Does it have to be a physical disk or can it be a partition?
That's a good question. I've done it with a full physical disk. I haven't tried it with a partition, right? So one of the commands in there was, it said full device. So there might be a different option to use a partition instead of a full device. Yeah, so I don't know for sure about that. Yeah. I just had the luxury of having a Mac Pro that had multiple slots available. So I just threw another drive there and went that way. Yeah, any other questions? No? Wow, I did all that great explaining, I guess. Sure.
Anybody who's dealing with Revit in this kind of a setup who'd like to talk or be given, I'll buy you a beer later. Come find me, please.
Okay. All right, anybody else? No? Okay, well, thank you very much. Thanks for spending some time with me today.